Although we're off with a good start, if you take a look at the simulation currently, you will notice a few strange things. First of all, there's a few pieces, for example, the fragments that would be fixed to the geometry, are emitting a lot of particles, which seems strange. Also, there's a few of these small pieces that are traveling very slow, that are emitting a lot of particles, even almost the same amount of particles that these ones that are traveling very far and very fast. So what I would like is just the fastest traveling pieces to emit the particles, and the slower pieces shouldn't emit particles at all. And to do this, we need to implement a little bit of vex, but it's not complicated. You will notice that it's a very simple vex. So let's go back to frame 1. Let's jump back to our sub context. And just below the blast node, remember here we are blasting the entire outside pieces. I will add a point wrangler and call this set speed. So we're going to create an attribute called speed that will measure in real time how fast the pieces are moving. And later we will use this information to create the emission. So let me scroll forward just a few frames, and I will create a visualizer. So here on the visualization button, you can right click and click on the plus sign to add a new marker. I will add a marker called V with a label called V to represent the velocity attribute. And just make sure that the type of marker is vector. And then click close. So notice how these lines are representing the velocity vector of each point. And of course, the longer these lines are, the longer the vector is, or the greater its magnitude. So what I want to do now is discard the pieces that have very low magnitude, so they are not emitting particles. Just keep the ones that are moving very fast or have a very high magnitude. So let's turn off the marker, and on our point attribute, type f for floating value at speed is equal to the length. So length is a built-in function for vex. So you can type length, open parentheses, close parentheses, and don't forget a semicolon. And inside the parentheses, we will type v at v, which is the velocity vector, and then press Ctrl Enter to evaluate. So the length function will return the magnitude of the velocity vector. So let's take a look at the geometry spreadsheet, and let's see the speed. You will notice that some of the points have a speed of 0, the ones that are not moving, of course, and the ones that are moving faster have a speed of 23 meters. So what we can do now is create another point wrangler. Call this one kill by speed. And we'll create an if statement that will analyze how fast the points are moving. And if they're moving slower than certain threshold, they will be deleted. So type the following code. If, open parentheses, f at speed is lower than, and we will create a channel for this. So to create a channel, type ch, open parentheses, and add a name. So type quotes, and the name can be whatever you want. I will type threshold, close quotes, then close parentheses. And what will happen if this value is lower than the speed attribute? We will remove the point. So type remove point. Again, this is a vex function that will delete points from the geometry. So open parentheses, type 0. 0 is representing the current geometry or itself. Then type comma at pt num. So remove itself from the geometry. Now we can close parentheses and type semicolon and Control Enter to evaluate. Now there's a typo here. I am missing a closing parenthesis here. So again, evaluate. And we need to create the actual channel. We haven't created this. So click here on the button to the right. And notice as we increase this value, some points will be deleted. And you will notice that the slow moving points are the ones that are being discarded. So let's keep a value of 8. And again, let's check the simulation. And this is much better. You will notice now we don't have these static pieces emitting particles. I still have some slow moving pieces that I would like to remove, but that would be very simple. We could just go back to our kill by speed node and increase the velocity threshold. Let's say 11 meters. Let's view this through the camera. And this is looking much better. Of course, this is a matter of taste. You may want to go higher or even lower. But for now, I will go with this.